Somewhere inside you, a gene is slowly turning up like a dial, and as it climbs, your muscles begin to forget how to repair themselves. You will not feel it today. But after the age of 30, your body starts losing 3 to 5% of its muscle every decade. By the time most men are old, roughly a third of their muscle is simply gone. For over a century, we called this aging and left it there. Muscles wear out, bodies slow down, nothing to be done. That story was wrong. In July of 2026, a team at Duke NUS Medical School in Singapore found the dial, a single gene, quietly rising for decades, sabotaging the machinery that keeps muscle alive. They called it DEF1. And what they discovered next is stranger than the decline itself, because they also found the switch that turns it back down. To understand what breaks, you first have to see what a healthy muscle actually does every single day. It is never still, even when you are. Inside every muscle cell, two crews work around the clock. One builds new proteins. The other tears down the damaged ones and hauls them away. Health is not strength, health is balance. Build and remove in a rhythm so steady you never notice it running. When that rhythm holds, old damaged proteins get cleared before they pile up. The cell stays clean, the muscle stays ready. But imagine the removal crew slowing down while the builders keep working. Now junk accumulates. Broken proteins clog the cell like a factory that never takes out the trash. That buildup has a name in the aging body. It is one of the quiet engines of weakness, of falls, of the slow loss of independence that steals years. And here is the unsettling part. The thing that slows the removal crew is not damage from outside. It comes from a command written in your own genes. That command is where DEF1 enters. To see how one gene tips the whole balance, we have to follow it down into the control room of the cell. Meet mTOR1. Think of it as the cell's growth accelerator, a pedal that tells muscle when to build and when to hold back. Pressed correctly, it is essential. It is how exercise makes you stronger. But a pedal jammed to the floor does not build. It floods. When mTOR1 runs too hot for too long, protein production overwhelms protein removal. The balance we just watched tips. The trash piles up. So what jams the pedal? This is what the Singapore team traced. DEF1 is not just any gene. It is a transcription factor, a master controller. They mapped where DEF1 grabs onto the genome and found over 16,000 landing sites. And one of them sat directly on the control switch for mTOR itself. That was the smoking gun. Rising DEF1 reaches down and turns the growth pedal up, keeping it pressed when it should ease off. Worse, DEF1 also settles near the genes that run mitophagy, the cell's system for clearing out its own broken power plants. The cleanup crew quietly cut off. For most of your life, none of this happens because DEF1 is held on a tight leash. Something stands guard over it, keeping the dial low. So, the real question flips. It was never why DEF1 rises, it is why the guard that restrains it walks off the job. The guards have a name, FOXOs, a family of proteins whose job is to keep DEF1 quiet and the repair rhythm steady. When FOXOs are active, DEF1 stays low. The removal crew keeps pace. The muscle clears its damage and holds its strength for decades. But FOXO activity naturally fades with age. The guard grows tired, and the moment its grip loosens, DEF1 climbs, unrestrained. That is the whole machine of muscle aging in one line. Guards weaken, the dial rises, the pedal jams, the trash wins. Now the discovery that changes the story. The team asked a simple question. Is there anything that wakes the guards back up? There is, and you already own it. Physical movement activates proteins that push FOXO back into action and drive DEF1 levels back down. That is the switch, not a drug, not an injection. Exercise reaches into the control room and resets the very dial that was aging the muscle. They watched it happen. Lower DEF1 and the removal crew comes back online. Damaged proteins clear, the muscle rebuilds and holds strength again. This was not a lucky result in one animal. They raised DEF1 on purpose and watched muscle weaken faster. They lowered it and watched strength return, and it held across wildly different creatures, from fruit flies to aging mice. A mechanism this old and this shared is almost never a coincidence. Here is where an honest study refuses to sell you a miracle. The switch works, but it comes with a condition most headlines left out. Exercise resets the dial only if the control system is still able to listen. The wiring has to be intact for the signal to land. In some older muscle, DEF1 has climbed too high or FOXO has faded too far. The guards are not just tired, they have nearly left entirely. When that happens, movement sends its signal into the control room and almost nothing answers back. The reset barely turns. This may explain something doctors have seen for years. Two people, the same age, the same workout, and only one grows measurably stronger. It was never only about effort or willpower. Underneath, one body still had a responsive switch, and the other had let it drift too far. That is a harder truth than a slogan, but it is the useful one. The machinery responds best while it is still listening, earlier than most people think to start, and it reframes movement entirely. Each time the body moves, it is not just burning energy, it is reaching in and holding a dial down that age keeps trying to raise. Which leaves one last question the study quietly opens. If a gene can be turned down by movement, could it one day be turned down another way? That is exactly the door this study opens. Knowing the switch has a name and a location means it becomes a target medicine can aim at. For populations aging faster than ever, that matters. A therapy that mimics what movement does could reach people whose bodies can no longer do it themselves, but that is tomorrow's chapter. Today, the finding is quieter and larger. The slow fade we blamed on time turns out to run through a switch we can touch. Your muscles are not simply running down, they are being turned down, and somewhere in that difference sits everything science is still trying to reach.